All right, so here's our last method. I've written out the steps here. Just real quick, I'm going to go over these so I can get to the two examples here. So the first three steps are the same. All right, same as all the other ones we've done. You find your total population, you find your IR, you find your quota. All right, so now the next step for HillMethod, it's based off a geometric mean. So what you do is you take this quota and you see what it falls in between. If it's like 15.378, that falls in between 15 and 16. So 15 is your lower quota, 16 is your upper quota. So you find what two numbers it would fall in between on your number line. So you would list those. Okay? And then you take the geometric mean. This is a geometry term, actually. So geometric mean is something you should have done with right triangles and things. And so all geometric means is I'm going to multiply these two quotas and then take the square root. It's not the arithmetic mean, it's the geometric mean. All right, and so my initial allocation then, I go back to the original quotas in step 3. I look at those, and I compare it to whatever I got in step 5, geometric mean. If quota is greater than, then I allocate upper. If quota is less than geometric mean, I allocate the lower quota. Okay, that's my initial allocation. Then I total up that initial allocation. If that number is the same as the number of seats to allocate, you're done. You don't need to adjust your IR. However, if it's too low, you're going to have to lower your IR. If it's too many seats, you're going to have to raise your IR. Okay, that part is very similar to Webster. All right, so these are the steps. Now let's put them into action and let's do an example here. Okay, so let's begin with 130 seats we're going to allocate. And we're going to allocate it to let's do 4 groups. 793, 924, 652, and 831. All right, these 4 groups with those populations. First step, find your total population. Add all those up. There you go. I added them up, I get 3,200. Next step, I take my total population and divide it by the number of seats. I get my ideal ratio, also called standard divisor, and I get 24.6154. Giddy up. All right. So next step is the same for all of them. You're going to find your quota. So you can take your group size and divide it by your ideal ratio. That doesn't change for any of the methods. So this is 32.2156. This is 37.5375. This is 26.4875. And this is 33.7594. The way I got all those, I took my group size divided by my ideal ratio. All right, so this is where this gets different than the other ones. And HillMethod, Huntington Hill method is the method that is still used today for the House of Reps. All right, so I take the lower quota. So basically, what two integers does this fall in between on a number line? Well, 32 and 33. Another way of looking at this is the lower quota is truncated. Add 1 to truncated, and there's your upper quota. All right? This is 26, and it's in between the numbers 26 and 27 on a number line. This is 33.7, so it's between 33 and 34. Those are my lower quota and upper quota. And now you're going to calculate your geometric mean. So remember, your geometric mean is taking the square root of lower quota times upper quota. All right, so I multiply these, round to 4 decimals. This is very, very key. I multiply 32 times 33, and then I take the square root. So I have 32.4962. These are going to be very, very close to the arithmetic mean, but should not be the arithmetic mean. 37.4967, 26.4953, and 33.4963. Once again, the way I got those is I multiplied my upper and lower quotas together and then took the square root of that. Okay, so here's Hill initial. All right, you're going to compare quotas to your geometric mean. If it's greater, you can take the upper quota. You compare quota to the geometric mean. If it's less than the geometric mean, you take the lower quota. All right, so here's what I'm looking at. Quotas and geometric mean. Quota is less than. Take the lower quota. So that's 32 for that first one. This is bigger than the geometric mean. Quota is greater than. So take the upper quota, 38. This is less than. So you're going to take the lower quota, 26. And this is bigger than that. So you take the upper quota, 34. So you add all these together, and notice I get 130. So I don't need to adjust my IR. So there would be a column probably that says, what Hill quota did you use? Just like with Webster, we don't leave any column blank. And how did you find, what is the final allocation? Well, since I don't have to adjust anything, my Hill quotas are the original quotas. Quotas, not geometric means. So these are the quotas when compared to the geometric mean. I get the proper allocation of seats. And so how did I allocate these? Well, the initial hill is the one that adds up to that. Okay? That's nice. It's really nice when your initial equals your seats. You don't have to do anything, just like with Webster. You don't have to adjust anything. Okay? You don't have to adjust anything. All right, so let's do one more. And maybe we'll have to adjust here, and we'll show you the way you can, or how you can do that. All right, let's say you have 215 seats, and let's do a few group sizes here. Okay. All right. So let's say we have 576 is one group, 839 is another group, 621 and 427. All right, so we're going to total those up. And there's your total population. Next step, find your IR. 2463 divided by 215. All right, so my IR is 11.4558. Whoops, 0.4558. Okay. All right, so find your quotas, just like we did in all the other ones. So I'm taking group size and I'm dividing it by this. So I'm going to write these out. 50.2802. 839 divided by that is 73.2380. 621 is 54.2083. And 427 is 37.2737. All right, so for this method, for Hill, Huntington Hill, we find the lower and upper quotas. What two integers does that fall in between? 50 and 51. 73 truncated plus 1. All right, 54 and 55, and 37 and 38. All right, so remember the geometric mean is multiplying. Geometric mean is multiplying your lower quota and upper quota and taking the square root. Okay, so geometric mean is lower quota times upper quota, and then taking the square root of that. All right, so 50 times 51, take the square root of that, 4975, 50.4975, 73.4983, 54.4977, and 37.4967. All right, so let's do our initial hill down here. Quota, remember, quota greater than geometric mean, you take the upper quota. Quota less than geometric mean, you take the lower quota. Okay, so this is less than, so that's the lower quota. That is less than that, lower quota. That is less than that, lower quota. That is less than that, lower quota. So when you add these up, I'm one away. Okay? So if we use our same reasoning we did for Webster, I'm looking at these quotas and thinking, all right, so I want one of these to be 0.49, higher than 49. Whatever these are. Okay? So I'm trying to figure out which one I can get to be higher than that. So I tried, first one, the biggest one, I tried this. Okay, so if I would make that 50.5. So this is, I'm going to try a new hill quota. So I'm going to make this 50.500 because that'll be greater because that still falls in between. All right, so what IR did I use there? Well, that's taking the 576 and divide it by this 50.5, and I get 11.4059 because I didn't have enough. So I needed to lower this a little bit. All right, so once I take all of these group size and divide it by this new IR, this is my new, here are my new quotas. All right, I'm doing this very quickly, I know, but you can always pause it and go back. Okay. All right, so now I compare these new quotas to this guy. And so here's my new hill allocation. And so this is bigger, so I take the upper quota. This is now bigger, so I take the upper quota. This is smaller, so I take the lower quota. And that's smaller, I take the lower quota. Notice, though, now I have one too many. Okay, that was too much. I went too high, or in this case, I lowered this too much. So it's got to be in between these two somewhere. All right, so it's not going to be very, very high, though. It's not going to be that much higher. So maybe if I just make this guy go, this is almost less than that. Almost less than that. If I make this less than that, maybe this one will stay above that slightly because this is above that. So let's try taking 50.49 and dividing that into my, and see what new ideal ratio I can try there. All right, so this rate, look how little that raised it. And let's see if this works. Okay, so there's my new hill quota again. I'm going to just list these. And we're going to see if this one works. All right, so the first one is 50.4900. Because I took this and I divided it into 576. Okay. All right, so if I continue doing this, I have 73. This goes down to 73.5436. I took my new IR and divide it into these groups. Okay. And then I take this and divide it into 621. I get 54.4345. And I take this and divide it into 427. I get 37.4292. Now I don't need to recalculate my geometric means because these numbers fall in between the original geometric means. So this is 0.4975. This would be 73.4983. This quota falls in between 54 and 55, so this would be 54.4977. And this is 37.4967. These still fall in between those same numbers to give you that same geometric means. All right, so now the Hill method, look what happens here. This is less than, so that's the lower quota of 50. This is greater than, that's the upper quota of 74. This is less than, that's the lower quota of 54. This is less than, that's the lower quota of 37. And when you add that up, I get my 215. So it took me a couple chances there, so that's why Huntington Hill is obviously the more difficult of all of ours. It took me a couple chances to get there. Once again, we'll go through this again in class, do a couple more examples. All right, and if you have questions, watch this, please try it. Come in with questions. It makes it a lot more interesting and a lot easier for you to understand when you come with questions. All right, enjoy the day and giddy up.